Okay, let's start our course from a very fundamental topic that's not even exclusive to Coda. It's a core of any computations in any programming language or any system like this. And the topic is expressions. So what are expressions? You might have not heard this word in context of Coda because they are using a different word for it, but as I said, I will be introducing a new vocabulary and you'll see, and I'll shortly explain why I'm doing that. So, what is an expression? So, this is an expression, right? 1 plus 2 equals 3. It's an expression that calculates something and returns an output. This is also an expression. It's just a number, and the expression it's just one value, and it returns itself. It outputs a number. In the first case, it also outputs a number, by the way. And this is also an expression. This is how expressions can be. And what it does right now, it outputs, so here's a table of tasks. It does some computation over that table of tasks. Specifically, what it does is that it finds all tasks where an assignee has at least one task that's not completed, which is sort of self-referencing formula. And if any were found, it outputs a bullet list of these tasks, and if none were found, it just outputs a text that no tasks, nothing to output here. And it's also an expression, and even though it's not completely obvious one for you right now, might not be an obvious one, it is still an expression in terms that it calculates something and it returns one value, a text value. And by the way, the bulleted list of something is still a text value. It's not a list. It's a text value because it looks like text. All the text elements, formatting, paragraph formatting is what makes it text. And here's yet another expression. And it also returns a value. And you might say, okay, no, it returns a list of values, it returns a list of 3 numbers, but no, it still returns one value, and that value is a list of numbers. So what is common for these 4 expressions? There are just 2 rules so okay, what is an expression really? An expression is something that is a piece of formalized code or whatever you use to describe what needs to be calculated. So what it does, it calculates something and it outputs just one value. So each expression outputs one value, and that value can be of a different type. And the fact that many people who weren't working with programming before cannot grasp or have a hard time grasping is that each value has a type, and a list of values is also a type on itself. So here you still get just one value, a list of numbers. It's a value of a type, a list of numbers. And if you get, for instance, an expression that just returns all rows from the table tasks, it also returns you one value which has type a list of rows from table tasks. Or if you return just one row, like let's say the first row from the table tasks, this expression returns you one value which has a type a row from table tasks. So even if it's a list, even if it's a list of lists, even if it's a list of objects or a list of objects or a mixed list or whatever, a text, a number, a duration, whatever, it's just one value. So ultimately, each expression calculates just one value. And another thing that some people may find mind-blowing, and it's the second rule of expressions, is that whenever in an expression you can use a value, let's say here for a 1 plus 2 formula or 1 plus 2 expression, you have a number on the left and number on the right. In the place of a value, you can use another a sub-expression, another expression that returns a value of this type. So instead of 2, you can type in a sub-expression that calculates that number to, let's say, 4 divided by 2. Or it can be something, let's say, the table of tasks, the count of the table of tasks. This expression returns a number, a value that has a type number. And you can use it wherever you would have just used a number. So you can substitute in an expression wherever you have a value, you can substitute it with another expression that returns a value of that expected type. And that's like, I don't know, apparently that's mind-blowing for many people, because what Coda documentation teaches you is that, for instance, if you're using a filter function, you use it like you have a table, then you remember those tutorials about how you write a formula like a story. It has a beginning, a middle chapter, and an end. So you use a tasks as tasks, then you use some filter or on current value, I don't know, status is completed, and that's how, and then the count of tasks, of completed tasks. So the big truth is that the filter formula expects a list, and it can be any list. It behaves differently for a list of rows and for a list of arbitrary numbers. But let's say a formula filter on a list, right, on a tasks list. A filter function that's run on a tasks on a list of from some table, on a list of rows. It also returns a value of the same type, a list of rows from table tasks. Maybe a shorter one, but it's still a list. So this one is the list of row from table tasks, and the filter one is the a list of row from table tasks. So it's the same type of the value, maybe a different value. It has a different absolute meaning to it. The fact that the first one returns all 6 rows and the second one returns just 3 rows, but it returns a value of the same type. So instead of just typing in tasks, we can use another filter here, for instance, that let's say we filter by assignee. And the fact that this returns just the value of the very same type as simply writing the tasks table would. And also the filter function, it doesn't necessarily work on list of rows. So let's say we have a tasks filter, so it lets all rows through if the filter, it lets a row through if a filter calculates, if an expression within a filter calculates to true, right? So if we just type in true, instead we do the opposite thing. Instead of writing an expression that calculates to true or false, we simply write true or false directly in the filter. And this way we say that let all the values pass through. And remember that here we have a list of values, and it expects any list. And in our case, it doesn't try to look into what's in that list, if it's a row or anything. So we can substitute this list of tasks with anything, an empty list, and filter it on true. A list of 1, 2, and 3 filtered by true. So we can supply any list, right? I hope you understand the logic. Or we can have a list of text values and pass it to the filter function. What matters is that a filter function expects a list as a parameter that's passed to it. So it doesn't matter for the filter function if it's a list that if you're reading directly from a table, or if it's a list of rows from that table, or it's a list of rows from that table but you got it in some other way, be it from another expression, a pre-filtered formula, or maybe you have something like in this column you pull in all the tasks by the same assignee. Let me just quickly, and you have here a list of tasks, right? So you can have something like tasks first row value of column 5, it's also a list of rows from table tasks, and you can go on and filter on that. Current on status equals completed. Not really sure why it didn't. Should have worked. Fun fact, I'm not going to re-record this, at least not now. Might be that this thing still acts up. Yeah, there's still some issues about how you select the first row or the first column or whatever. But anyway, this returns you a list of rows from table tasks. So it means you can do anything on it that you can simply do on a whole table of tasks. So that's how you substitute pieces of an expression with something that has the same data type. And just another example, and it's an example of one of my patrons, Virginie, or Virginia, I'm sorry if I'm mispronouncing your name, and one of another community champions who was apparently confused by this or mind blown by this use case. So there's this format function that takes the first text as an as a template and then fills in the 1 and 2 in curly braces with parameters. Let's say the text is tasks first, or no, let's do it a different way. So we have a column, we want to have a nicely formatted assignee, task, and combine and their status. So this will be assignee, task name, and the status, right? So we have it like that, a combined way of doing things. And here you may see that we are using the first parameter is a text value that defines the template, and we specified it right, here in the function. But what we can do, we can either specify this text value and make it a named formula. So let's say task summary. And we made a named formula, means we can now refer to it. And we can replace the text value, but that task summary named formula. And what it will do, it will read that text value from that formula inserted here. So for a format function, it doesn't matter if it's the template right here or if it's reading it from anywhere else. What matters is that it expects the first argument of this function to be a text value. Or you can go even further. You can make a new table of, let's say, name it templates. And this is gonna be a template name, and this is gonna be a template value, and let's say it's a task summary template, and its value is 1, 2, 3. And we put it in here, and it's a text value because it contains text. And we can, instead of using a named formula, we can link to that task summary row from that templates table. Take the value from there, which is this text value. So this expression reads a value from a table and returns a text value. And that text value is used as the first argument of the format function in place of the actual text. And this still works, and this will work. And I can now, in a centralized way, in an obvious way, instead of modifying formulas, I can go and just modify a text value in here, and it will apply that change. It will apply that text value in all of the values here calculated by the format. Or I can go and make it, I don't know, a heading, and I just need to prepend it with something, so like a task. And now it applied the styling to these values. Or I can make it back to text value, to the text formatting level. So yeah, that's the big secret behind all that complicated logic that you can do with expressions. And again, why am I calling them expressions? The Coda calls them formulas. Well, the truth is, even Coda doesn't call them formulas all the time. Formulas, I think it borrowed this word from Excel because things that you calculate for a row are called formulas in there. But in Excel, in Coda, and in general programming world, there are a few separate names. So an expression is a generic thing, something that calculates one value of a certain type. A formula, what I like calling a formula, I can say that the whole column, for instance, is a formula column. So the whole expression, the big expression that calculates each cell of each row in a column, it's a formula. Or a something that belongs on a canvas that calculates some piece of text is a formula. So this is a formula, this is a formula. This is like the whole thing here is a formula, and this whole thing is a formula, but also this formula has this text as an expression. This is the expression of that formula, or this is the expression of that formula. And this is sort of a sub-expression that's used within a filter function. And those individual things that you have in the Coda.io/formulas reference. So again, Coda calls them formulas, but the contains, all the contains, list combine, list, nth, etc. Something that has a name, opening and closing brackets, and the list and the rules about arguments, which arguments they use. Universally, they are called functions, because a function is something that, like a black box, it calculates something. You don't necessarily have access to how it functions within itself. It takes in some arguments and it outputs a value. Again, it outputs a value. So a function, there can be an expression that has just one function with some arguments that are passed to this function. Like here, list is a function that has 1, 2, and 3 as 3 of its arguments. What it does some magic within and returns a list, one value that's a list of numbers, or specifically the list of those items that are passed to it as 3 separate values. So these are 3 separate values, and this function returns a value that's a type, a list of that combines all these values that are separately passed to it within one list without modifying the values themselves. So list is a function. Filter is a function. With name is a function. Is not blank is a function. If in Coda's world is also a function. And what we pass to the if function, this is an expression, this is an expression, and this is an expression. And yeah, back to why I'm naming these things as such, and why Coda is naming them as functions. So Coda names them as functions because this is familiar to Excel users. Everything is called, formulas. Everything is called a formula in Excel language. But even in Coda, why it's important that I teach you the proper name of these things? Because even in Coda, if you start looking into documentation of some functions, for instance, you look into the if function, and it already tells you here condition. It's an expression that outputs true or false. So this if function expects here a value or an expression that returns a value, specifically a logical value that's either true or false. And if true, a value to output. Here it doesn't say it's an expression, but it can be, if true, it can be either the value, or again, it can be something that, it can be an expression that returns a value. So you can substitute that. If you look into into functions like switch if, you can already see that even though Coda names these things parameters, they are time to time, because they are engineers, right? Engineers worked on this platform, were building this platform. they will occasionally name them arguments. That's the name of what you pass to a function. One value, multiple values separated by commas, they are for function arguments, arguments of a function. So they will occasionally call them arguments themselves. Like here you see the arg word, which is a short word for arguments. And again, with name, it uses a word expression here. And maybe you wouldn't find a word function within the documentation. I don't know, I haven't found it. Maybe I have encountered it, but I totally forgot where it was used. But just generally speaking, anything that Coda is built on JavaScript, and JavaScript is a functional language, and Coda, as I'll show you later, borrows a lot of its logic from JavaScript and, well, behaves a lot like JavaScript would behave. So it's very natural to call these things functions. And if you Google what a function is, you will pretty much find a similar explanation to what I've just told you. Something that takes in some arguments and outputs and calculates a value. And something that's atomic, something that you don't necessarily know how it works inside. So yeah, that's the introduction on expressions. Hopefully this is helpful already, and I'll see you in the next video when I'll talk more in detail about operators, and then the third video will be about functions. Cheers!